We're going to start out by looking at this GeoGebra activity that's really kind of interesting. So I'm showing you on lesson 9.3 page where you can find it. If you want to go there, that would be really great because it will help you understand this. And it's the law of sines, so you just click on this law of sines. And it opens up this really cool activity, which it has a triangle already built and has the points A, B, and C on the triangle. And notice something, that angle A is always opposite side A, angle B is always opposite side B, and angle C is always opposite side C. And the cool thing here is you can move these points and you can make any shape of a triangle that you want. You can make an obtuse. You could even try to make a right triangle if you're really careful and try to get that to be 90 degrees. You could make a cute triangle. You could make isosceles, whatever you want. So what you want to look at while you're moving these around is these points over here represent the angles A, B, and C. Alpha, beta, gamma, but they're corresponding to angle A. The ratio is what we're going to look at because look, watch that ratio. No matter how I move this, the ratio, and what we're doing is the sine of A over the distance of A. So that's what the ratio is. The sine of A over the distance A is the ratio. And just notice, yep, it doesn't matter how I move that triangle, that ratio always stays the same, which is really cool because now we're going to be able to use that information to help us find area. So if we're finding the area of a triangle and we don't know, well, it's not a right triangle because if it were a right triangle, we'd use Pythagorean theorem. But this way we can do it for any triangle as long as we know 3 pieces of information. So looking back at your notes, we call this formula the law of sines because it's the ratio of any of the sine angles. And we are going to use the law of sines if we have 3 pieces of information. We have to know either 2 angles and a side or 2 sides and an angle, but they have to be in a specific order. And I know this looks like in Math 2 when you did a triangle congruence, looking at angle side of one triangle and to the other, but we're just going to use those same letters and combinations for knowing when we can use the law of sines. And what this means is angle, side means that we have an angle and a side, and the side is not between the 2 angles that we have. So if we have angle A and angle B and side A, or angle A and angle B and side B, then we can use the law of sines because we could do the sine of A over A and the sine of B over B or whatever. So that's one combination that we can use law of sines for. Angle, side, angle. So that one is 2 angles, but the side is in between the 2 angles. So like angle A, angle B, and side C. Or angle B and angle C and side A. Now, the reason why we can do that, think about that for a second, if we know 2 angles of a triangle, we can always find the third. So think about how we could do that. But then the last one is side, angle, and we write it this order because it's socially unacceptable to write it in a different order, right? So we have a side, and an angle, and the angle is not between the 2 sides. So side, angle, so like angle A, or side A, side C, and angle A, side B, side C, and angle B. So put that in your notes, but you could always just think about it. You know, when could you use the sine of A over B? So like if you were looking at using this part, because you're only going to use 2 of the 3 ratios. So you have to know 3 of the 4 pieces. So if you have a problem that you know the angle A and angle B and side A, you could find side B or any of the other combinations. So that's pretty simple. You just look at what you know and see if you have enough information to write a sine ratio. Okay, so here is the law of sines. Be sure you get these all written down in your notes so you can refer to them. The law of sines is the ratio of sine of A over B is equal to the sine of B over B, which is equal to the sine of C over C. We only use 2 of the 3 ratios in our formulas, but all 3 of them would work. This also is true if you want to set it up so that it is the side over the sine of the angle. Either way works. I usually just do the sine on top just because that's the way that I'm used to. Let's look at a problem. Okay, so in geometry or in trigonometry, when it says solve a triangle, I know we've talked about before, like, what do all the words in math mean? Well, to solve something means to find the answers. And when you are solving a triangle, that means that you're finding all 6 pieces of that triangle. Every triangle has 3 sides and 3 angles, and you are going to solve the triangle, which means you're going to find all 6 pieces. Now, sometimes you'll be given 3. You might only be given 2, and you would be able to find the third piece of information. So here's an example. So this is in your notes, number 4. So in this triangle, we have angle B, angle C, and side B. We are missing, think about this for a second, what are we missing here? We're missing angle A and side C and side A. So those are the things we're going to look for. So try these out. Think about that for a second. Remember previously I just said, now think about this for a second. How could you find that third angle? How would that be possible? So if you know 2 of the angles of a triangle, all the angles of a triangle add up to 180. So if you take 180 and subtract 107, which is angle C, and 25, which is angle B, you get 48. So angle A is 48 degrees. So now you've found 4 of the pieces. We still have to find side C and side A. I know that I have angle B and side B. So I'm going to set that ratio up. Sine of 25 over 15. I get that from here. The sine of B over side B is equal to, and let's find C first. It doesn't matter the order of how you do this. Sine of 107 over C. So C is our unknown. Now here is where I'm going to show you a really cool trick, because I want you to think about how do you solve a ratio like this. Now you could think of cross multiplying and finding the answer, which you'd get C times sine of 25 equals 15 times sine of 107, and then divide each side by sine of 25. But here is the shortcut. So to find C, I'm going to put my cursor right here so I know my unknown is here. So that means I'm going to multiply these 2 values together. And earlier I gave you a big hint. Don't put sine of 107 in first. Put the 15 in first. Then you don't have to worry about if it's all messed up. So you're going to go 15 times sine of 107. Find an answer. It's always easiest to find an answer first and then divide by sine of 25. You're not going to mess up that way. You're not going to, your calculator's going to know what to do there. And you should get the answer of 33 point something something that rounds to 0.9 with it being the nearest tenth. Okay, now I want you to try that on your own, because if you're not trying these on your own, you're not going to remember how to do them. Moving on, we got the sine of 48 over A equals the sine of 25 over 15. I'm using that same ratio that I already know. I could have used sine of 107 over 33.9. Doesn't matter. So again, my unknown is right here. So I'm going to multiply 15 times the sine of 48 and then divide by the sine of 25. And I get 26.4 for an answer. Try that on your own, and if you don't get it, try it again. Next one in your notes, solve the triangle ABC, round answers to the nearest tenth. I know angle A and angle C and side B. So how are you going to start this problem? First thing I did was found angle B, because 180 minus 71 minus 60 is equal to 49. Then I'm going to solve for side A. I know the sine of 71 over A is equal to the sine of 49 over 21. On this one, I either had to solve for A or C, so my ratio that I know is going to be B, because I know angle B and side B. All right, here's my unknown. In the calculator, put this in. 21 times sine of 71, find an answer. Divide that by sine of 49, you get 26.3. How we find C is we take the sine of 60 over C equals sine of 49 over 21, using that same ratio. C is equal to 21 times the sine of 60, find an answer, divide it by sine of 49, round it to the nearest tenth, you get 24.1. And moving on. Next one in your notes says solve ABC, round answers to the nearest tenth. Again, I know A and B, so I'm going to find C first. 180 minus 29 and minus 85 is 66. Then I know B, angle B and side B, so that's the ratio I'm going to set up. Sine of 85 over 9 is equal to, let's find A first. Sine of 29 over A. Here's my unknown. 9 times sine of 29, find an answer, divide it by sine of 85. A is equal to 4.4, rounded to the nearest tenth. Another thing I forgot to mention on the earlier problems, I always check to see if that makes sense. Does 4.4 fit with the rest of the triangle? Well, B is 9 and B is the biggest angle. So side B is going to be the biggest side. Remember that opposite side theorem that says that in a triangle, if the angle that's the biggest, the opposite side is going to be the biggest. So A is 29. That's the smallest side. So of the sides, 9, 4.4, and 8.3, A is the smallest side. So that makes sense. You can kind of check your answers that way. So sine of 85 over 9 equals sine of 66 over C. C is equal to 9 times the sine of 66. Find an answer. Divide by sine of 85. You should get 8.3 rounded to the nearest tenth. Next one, B and C is 70 degrees. So A is 29 because 180 minus 70 minus 81 is 29 degrees. Then I'm going to find B. So sine of 29 over 10 is equal to the sine of 70 over B. B is equal to 10 times sine of 70. Find an answer. Divide by sine of 29. That is 19.4 rounded to the nearest tenth. Now to find C, I'm going to use that same ratio. Sine of 29 over 10 is equal to the sine of C, which is 81, over C. C is 10 times the sine of 81. Find an answer. Divide by sine of 29. Answer is 20.4 rounded to the nearest tenth. Next one, number 8. This time we don't know two angles. So I'm going to start out with a ratio. I know angle A and side A. So I go sine of 115 over 20 equals sine of 11, or sine of B over 11. This time though, I find a decimal for an answer because that's the sine of B. So I have to take the inverse sine. So I'm going to walk you through that really quick. On your calculator, you're going to go 11 times the sine of 115. Find an answer. You should get 9.96, blah, blah, blah. I am going to divide that by 20, and I get a decimal of 0.4984. That's the big hint that we're going to do the inverse sine. So sine of -1 is blue on my calculator, so I'm going to use the second button, sign, and it shows on my screen, sign of negative.